Hello everyone. Today in this video we are going to discuss about the centripetal force and centrifugal force. Okay, we have also just read in the earlier video also that what is force, what are the applications of force, and in this video we will discuss the centripetal force and centrifugal force. So we know that every force has the ability to change the direction of motion of the particle, or we can say that the force has the ability to change the direction of velocity also. Means if a force is able to change the direction of any body or a particle, since the force is able to change the direction of the velocity of the particle or a body, obviously it has the ability to change the direction of a acceleration also. That is, if suppose if a body is just moving in a circular path, we already know that suppose this is a diagram I am just representing here. A body is moving in a circular orbit, circular path A B C D. Okay, and if a body is just moving in a circular path or a orbit, we know that each and every particular instant of the circular path, the velocity changes. The velocity changes means the velocity is non-uniform, means each and every instant of the particle just which is revolving around the circular orbit, it is changing always. Its velocity will also change. Velocity is changing at each and every particular point, and thus the acceleration is also changing at every instant, because acceleration is nothing but it is the rate of change of velocity, and if velocity is changing, acceleration is obviously changing. And if velocity will be just a non-uniform or a variable, acceleration will also be the just a non-uniform. But one thing that you have to keep in your mind, that although the acceleration is just changing at each and every part, but the magnitude of the direction remains the same. This is the most important point that you have to keep in your mind, that although the velocity is changing at every instant of the particle, and we can just show the direction of the particle by just drawing the tangent. Okay, in each and every instant we will easily able to get the direction of the motion. So if the body is moving in a circular orbit, then the magnitude of the direction of the body remains a constant, although its velocity is changing at every instant, although its acceleration is changing. So what is happening here? A force is needed. Okay, if any body is revolving around the circular orbit, a force is needed to brought this change. What is that force? That force is a centripetal force. So what is the definition of centripetal force? A force which acts always at the center of the circle or a center of the circular path in which the body is revolving. While revolving, a force is needed which is always acts, then the necessary centripetal force which is responsible for any body to rotate in a circular orbit. Okay, so centripetal force is a force acting on the body. And centripetal force is that kind of force which is acting on a body in a circular path in a direction towards the center of the just circular path. I am repeating once again. Centripetal force is a force acting on a body. Centripetal force is that kind of force which is acting on a body, moving in a circular orbit. This is moving in a circular orbit in a direction towards the center of the circular path. Here I am just denoting here by an arrow here that it is also acting towards the center of the just circular path or a circle. This centripetal force is the only force which is responsible for any body to revolve around the just circular path or a circular orbit, and this is what we called as the centripetal force. This is what we call the centripetal force. Only this much you have to understand, that a force, if a body is just revolving around any circular orbit, then a force is needed, which is always acts towards the center of the circular orbit, and that orbit is called as the force which is needed to rotate the body in a circular path, and which always acts towards the center of the earth or a circular orbit, and that force is called as the centripetal force. Okay, we can take various examples. We can take suppose in an atom, an electron is just revolving around the nucleus, and what the force of electrostatic force of just attraction by the nucleus on the electron is just provides the necessary centripetal force which hold the just electron to revolve around the just nucleus. So this is one of the most important example. Also we can take the case of our planet also. All the planets are revolving around the earth, or all the planets are just revolving around the sun, and the force of gravitation by the sun on the planets also always provides the necessary centripetal force, and that is the main responsible for all the planets to revolve around the sun. This is one of the also example. We can take the example of moon also. The moon is revolving around the circular or path by the earth. The earth has its own gravitational force, and which provides the necessary centripetal force on the moon to revolve around the circular orbit. Okay, we can also take a very behavioral example, that is when we just a stone is tied on a string, and if you whirled around us, then what will happen? The tension produced in the string will provide the necessary centripetal force, and which is hence responsible for the just revolving the just stone. Okay, so all these are the basic examples we have just learned through, and now we will just discuss. This is all about the centripetal force. Okay, and what about the centrifugal force? Centrifugal force, we can say that it is assumed force, it is an imaginary force, or we can say that it is a fictitious force. Okay, in the real existence it is not real, means a centrifugal force is not real force, it is imaginary, or we are assuming that the force is here, that is called as the centrifugal force. Means what will be the definition? A force assumed that when a body is in the direction, when a body is to be acting on the body in a direction away from the center of the centripetal force. Suppose the centripetal force is acting towards the center of the circular orbit, and a centrifugal force is always just acting away from the center. Okay, means in centrifugal force is the opposite force of the just centripetal force. Means centrifugal force is just away from the center. It is just acting opposite to that of the in this direction. Okay, in this direction it is acting, okay, away from the centripetal force. So what is the main difference between the centripetal force and centrifugal force? Centripetal force is the force which is acts on any body to revolve around the nucleus, and is also acted just towards the center of the just circular path. And the centrifugal force is an imaginary force, it is a fictitious force, it is not real force, which always acts away from the center, that is opposite to that of the centripetal force. Okay, these are the basic just idea about the centripetal force and the centrifugal force. Okay, but one thing that you have to keep in your mind, that the centrifugal force and the centripetal force have equal magnitude. Means both these forces have equal magnitude. Okay, so these are all about the just centripetal force and a centrifugal force. Okay, let us just take an example to demonstrate that how centripetal force and a centrifugal force are just acting on a just creating a just response on a merry-go-round. This is a merry-go-round. We have taken experiment here. Just we have to demonstrate it. That suppose this is a merry-go-round. Okay. In the previous condition, suppose this merry-go-round is in a stationary position, and suppose a man is just standing outside the merry-go-round and is observing. It is an observer, and a man is just sitting on the platform of the merry-go-round. This is a man A. It is represented as A, and this is a P. P is the just ball which is just tied through a string on this platform of the merry-go-round. Okay. In the previous one, if the just merry-go-round is stationary position, the ball is also stationary. The tied, this is a tie and this is a string. String is also is just loose. It is loose now. In this case, it is now stationary at this position. But as soon as it start rotating, what will happen? The string will become tight. Okay, it provides a just a tension. It is having here tension in the string, and this becomes to rotate in a just a circular orbit of the merry-go-round. So what does this string, the tightness of this string hold? This tight of the just ball tied to a string to the platform of the merry-go-round just behaves. It provides a necessary centripetal force. This provides a necessary centripetal force towards the center of the platform, and this which is responsible for just holding this ball to rotate around the circular path. Okay. When just see another scenario that when the merry-go-round is just going rotating, what will happen? The man will observe the ball as it is rotating. Okay, it is rotating, but the man which is sitting at the center of the merry-go-round just appears as the ball is stationary in this condition. The ball is stationary at this condition. Okay, at every instant it is stationary. Why it is happen so? The man outside the merry-go-round is just appears as the ball is rotating, and the man sitting in front at the center of the just merry-go-round appears as the ball is stationary at every point. What is the phenomena? What is the reason behind this? The man is standing on the outside of the merry-go-round just appears as the ball is rotating. Okay, why? Because the tension produced by the string provides the necessary centripetal force. Okay, and it hold this ball to rotate around the nucleus. This is what the reason the man just standing outside the merry-go-round just behaves or appears to man which is standing outside. But as the man is sitting at the just at the center of the platform of the merry-go-round, what is happening here? The tension in the string provides the necessary centripetal force, and there is also an imaginary force which is just acting here. That is all centrifugal force, and we know that the centripetal force and the centrifugal force have equal magnitude. Okay, this will be cancelled out, and the net force on the ball will be 0, and this is why we just considering here that the position at the man is standing in the center of the platform is appears as the ball is stationary at every point. Okay, means here two forces are acting here, and these two forces just makes the resultant of all the two forces, that is centripetal force which is acting towards the center of the earth, and the centrifugal force which is acting outwards. This force, the net resultant of these two force becomes a 0. Okay, that is the main reason why the person sitting at the center of the platform is appears that the ball is stationary. It's always behaving as in front of the just him, this ball. Okay, at position A dash. Okay, the ball condition will be P dash. It's always a stationary position. Okay, these two forces are acting on the just man which is sitting at the center of the platform. Okay, this is why the reason behind this. Okay, what will happen when the if the thread or the we get string of the merry-go-round on which the ball is tied to a string is just broken, what will happen? In this case, the man standing on the outside just shows that appears that the ball is in a straight line. Okay, it is just going outwards to a straight line. But the person which is sitting at this position will here the two forces are acting here. The two forces are acting here, that is the centripetal force and a centripetal force, and the outside man is appearing as a only centripetal force. Okay, so it will behave as a, it is just moving in a straight line. Okay, just pt is a tangent. If you just it is just behaving as a straight line, but the person sitting at the center of the platform will just appears as, here two forces are acting, centripetal force towards the center of the earth and centrifugal force outside away from the center of the earth. So it will behave as a, it is just radially, it is just going in front of the him. Okay, means it is stationary always, but radially it is going outwards. Okay, so this is what we the conditions where the centripetal and centrifugal force are acting on all these cases. A student just go through, and up to this just go through. We will discuss the next topics in the next video. Thank you.